Have you ever experienced a fan or air conditioning running and no air was coming out, and then to find out later that the belt was broken, or even more ridiculous, the belt was on the floor, and then fingers start to point in every direction? It happens quite often. I will show you the fastest method to change airflow accurately. For now, we know that we change airflow for two reasons, either to get more or less air. To do that, you either slow down or speed up the fan by either adjusting or replacing the pulley. There are two types of pulleys. One is a fixed pitch pulley and the other is a variable pitch pulley. Fixed pitch pulleys has a simple characteristics. To change airflow, you simply replace the pulley. Also, you use the type and size of belt supplied with the fan. To change airflow on fans with a variable pitch pulley, you will need to adjust or replace and then readjust the pulley. A variable pitch pulley is adjusted by half cycles. Each half cycle is an operating position with a specific pitch diameter. Each operating position requires a specific belt size. This explains why the belts get chewed up or jump off track. Anyway, to change airflow, if you're from the Flintstone era, you will need the size and RPM of the pulley and do a two-step calculation to get the RPM and or size of the replacement pulley. That being said, we know that measuring the diameter of the pulley could be tricky. The pulley hub and drive shaft are additional challenges that could compromise the accuracy of the calculations. Therefore, you expend more time in adjusting the pulley several times to get the desired RPM. This process of changing airflow requires experience and a good chunk of time. Now we're going to show you how to change airflow fast and accurately. No experience, no calculations, and better yet, no training. Even a technician can change airflow accurately first day on the job. So here it is, our awesome Dynamic Duo Plus, the pulley diameter gauge, the pulley GPS, and the Plus, our navigator charts. This diameter gauge is made specifically for reading diameters of pulleys associated with HVAC. It is compact and does not straddle the pulley to read the diameter. If you can reach the pulley, you can use the gauge to read the diameter without directly overlooking it. The pulley GPS reads operating positions of variable pitch pulleys. Think of the pulley GPS as an address, just like your home address, a specific location, but in this application, it's a specific pitch diameter within a variable pitch pulley. The pulley GPS also reads belt size and the drive shaft or bore. The pulley GPS operates both in digital and analog mode. The Plus. The navigation chart provides the means of accurately predicting the airflow from one operating position to another operating position within a variable pitch pulley, as well as between pulleys. A fixed shift chart also comes with the diameter gauge. So let's say you want to increase the airflow by 20% on a fan with a fixed shift pulley. Using the diameter gauge, you read the diameter to be 3.75 inches. It's simple. You simply go to 3.75 inches on the chart, scroll to the right to the desired increase, and as you can see, you can either increase the flow by 11% or 27%. For an 11% increase, you will use the 4.15 inch pulley. And for a 27% increase, you will use a 4.75 inch pulley. And that's it. You're all done. Now for variable pitch pulleys. Let's say we want to change the airflow by 16%. In this illustration, we'll increase it by 16% and then decrease it by 16%. We read the pulley to be 5.35 inches, and the operating position is number 5. The belt size is B. Meanwhile, let's take a moment to discuss our variable pitch pulley navigation charts. Each variable pitch pulley has a unique chart. The chart is color-coded as a guide for belt usage. The belt code is at the bottom of the chart. Note that there are two charts per pulley. The top chart is for navigating within the pulley, while the bottom chart is for transitioning between belts. The coding mitigates premature belt failure and jumping off track. So let's continue with our example for a 5.35-inch pulley chart that's operating at position number 5. To decrease the flow, we scroll to the right. As you can see, we can either reduce the flow by 15% to 85 or by 17% to 83. If you decide on 15%, you will have to open the pulley by 1, 2, 3, 4, 5, 6, 7, 8 half cycles to operating position number 13, right here in the yellow area. In the yellow area, belt size B would be adequate. If you decide on 17%, you will need to open the pulley by 1, 2, 3, 4, 5, 6, 7, 8, 9 half cycles to operating position number 14 in the blue area. In the blue area, you will have to replace the belt with size C. So let's see what happens when increasing the flow. From operating position number 5, we scroll left. As you can see, we cannot increase the flow with this pulley by 16%. The most we can increase the flow is by 13%, 3% short of our target. So we need to replace this pulley, and this takes us to the inner pulley chart below. Variable pitch pulleys are like daisy chains overlapping. This chart shows all the overlapping pulleys, the operating positions in which the pulleys overlap, and the percentage of change. 3 pulleys that overlap a 5.35-inch pulley on the increase side are a 6.0 inch, a 6.5 inch, and a 6.75 inch. The 6-inch would increase the airflow by 11% and intercept the 6-inch pulley at position number 5. On a 6-inch chart, starting at operating position number 5, we will adjust the pulley to an operating position to increase the airflow by 3%. It takes one trip to the equipment and a single adjustment, and you are all done. You save time, a lot of time. No training is required, and there is no calculation. You get consistent and repeatable results each and every time. We welcome you to log on to our website for more innovative products that will help you do more, do it more safely, do it more accurately, and in less time.